Hello friends, welcome to Learn Math with Alex. In today's video, we are discussing the laws of indices. Okay, so the laws of indices. Now, before we get to the laws of indices, we need to know what indices are. Okay, just to explain the meaning of indices or to give you the definition for indices, let me do it with the help of an example. Okay, let's say for instance, I am multiplying a times a. Okay, so what's the answer I'll get? What is a times a? Okay, a plus a is 2a, but what is a times a? So a times a, I'll get it, it's a with a 2 on the top right. So it is called squared. So a times a is a squared. Again, if I say a times a times a is equal to a, this time around this smaller number will be 3 or a cubed. Okay, so these are one of the these are examples of indices. Okay, so these are examples of indices. Okay, so we have a bigger number and a smaller number on the top right. Okay, so when you see numbers written in this way, they are indices. Okay, so what I'm saying is we have a bigger number and a smaller number on top. Okay, so this number has a special name. Okay, so this number we call it a base. Okay, so this is a base, and this number on the top right of the base, it has also a special name. It is known as power, but you can also call it an index. Yeah, again you can also call it an exponent. Okay, exponent. Okay, so this is a base, this is a power, index, or exponent. Okay, so what is the relationship between the base and the power? So mind you, so this is is you can read this as a to the power m. So it is a to the power m. So this is one of the example of indices. Okay, so what I'm trying to say is this a to the power m, a to the power m. So let me take you back to this example that I gave you. So we said a to the power 3 is equal to a times a times a. Okay, so here's the relationship between the base and the power. So the power tells you how many times you're going to multiply the base by itself. Okay, the power or an index or an exponent tells you how many times you're going to multiply the given base by itself. As you can see, we are saying a to the power 3, so it means we're going to multiply this a by itself how many times? 3. As you can see, you can count 1, 2, 3. That's a 3 which is there. Yes, even here we have 1, 2. That's a 2 which is there. So the exponent or the power gives you how many times you're going to multiply the base by itself. Okay, another example is you can see this as numbers as well. Let me use numbers this time. 2 raised to the power 4. So this is read as, we can read this as 2 to the power 4. Okay, so this means you're going to multiply 2 by itself 4 times. Okay, so when you count 1, 2, 3, 4, that is the 4 which is there, and 2 to the power 4 is 2 times 2, that is 4 times 2, 8 times 2, we get 16. Okay. Okay, so this is the meaning of indices. So you see numbers with a smaller number on the right top there. Okay, so that implies they are indices. But there are also numbers, like for instance, if I have 3, okay, so when you just have a single number like that, it means it is raised to the power of 1, okay. So for this one, there's nothing that we can do. So 3 raised to the power 1, it is still 3, okay. Okay, now that you have an idea of what indices are, so let's get back to our main subject. So our main subject for today is the laws of indices. So what happens when you break the law? What happens when you break the law? Okay, we know when you break the law, you'll be jailed, you'll be punished. Okay, so even these indices, they have laws, or I can say rules, or anything. Okay, so they have a way of the way that they operate. Okay, you can just use them anyhow. Okay, so they have a certain way that you can apply them. So let's see how we can apply indices, or rather let's go into the laws of indices. Okay, so the first one, okay, so law number 1. So when you're multiplying indices, okay, so we said we have 2 indices now. So we have this one and this one. Okay, so in a situation that you're multiplying them, okay, and as you can see, uh, if you observe the 2 indices, the base is the same, but they have got different powers. Okay, so what happens when you're multiplying indices of the same base, or numbers with the same base? What happens? Remember, these are laws, so you apply them according to the way they are. Okay, so law number 1, indices of the same base. So when you're multiplying numbers or indices with the same base, what you do is they'll give you, it is, you just add the powers. Okay, so you have m plus n. Okay, so indices of the same base, when you're multiplying them, you just add the powers. So you get one base, okay, then you add the powers. I'm sure this is clear. Okay, let me give you an example. So e.g., if I'm multiplying 2 to the power 3, okay, times 2 to the power -1, okay. Yeah, remember I said an exponent can also be a negative, or we'll get to that, don't worry. Okay, so as you can see, the base is 2, it's the same. It doesn't matter whether the powers are the same or not. As long as the base is the same and you're multiplying, what you do is you say it is 2, then 3 plus -1. Okay, so this will give you 2, 3 plus -1, you get 2. So therefore this 2 to the power 2, we said it's 2 times 2, so this will give you 4. So that's law number 1. So when you're multiplying indices of the same base, you just add the powers. Okay, so you get the base, then you raise it to the sum of the powers. Okay, I hope it's clear. Please don't get confused. Common mistakes that people make. I'll give you an example. If I have a raised to the power m times b raised to the power m is equal to, so this can never be a, then you add a plus, sorry, m plus m, or anything like that. So this doesn't apply. Okay, so you only apply this law when the bases are the same. Okay. Okay, so let's move to our second law. Okay, the second law, let's say this time around you're dividing a to the power m over a to the power n. Okay, so what happens when you're dividing numbers of the same base? Okay, so remember the base is a, even so the numerator the base is a, the denominator the base is a, but the powers are different. Okay, so how do you go about this one? Okay, so when you are dividing numbers of the same base, you get the base, which is a, the common base, which is a, then you subtract the powers, so it is m minus n. Okay, I'm sure it is clear. There's no need to give you an example on that one. Okay, so let's move on to our third law. Okay, let's say I have a raised to the power m. Okay, again raised to the power n. This is usually called an index of an index. Okay, so I have this base raised to the power n, and everything here again is raised to another power n. Okay, so how do you handle this situation? Okay, so in this case you're going to say it is a, then you're going to get the base a, then you multiply the powers. Okay, so it is m times n, so this is the same as a to the power mn. Okay, so if you have a base raised to some power, again raised to another power, okay, so what you can do, the only thing that you can do, you can only multiply the powers. Okay, you can only multiply the powers. Okay, I'm sure that one is clear, friends. Okay, let's move on to the fourth one. The fourth one is what happens if I have a raised to the power negative m. Okay, so remember we said the relationship between the base and the power or an exponent, their relationship is the power tells you how many times you're going to multiply a by itself. But now, how many times, like, okay, in this case, now we have a negative number. How do you know? Okay, you know that you're going to raise a, you're going to multiply a by itself by negative m. How are you going to do it? So that becomes a bit tricky. Okay, so this one you can apply this law. So when you have an index or a base raised to the power negative, the only way you can get rid of this power, you say 1 over a to the power m, or vice versa. Okay, so in a situation when a number is raised to the power negative, if you want to get rid of this negative, you just replace this statement by that statement. Or if you have 1 over a raised to the power n, okay, you can, if you want to get rid of this fraction, you can go that way. Okay, so this is a two-way thing. So if you look at this one, so if you have a number and the base, sorry, and the powers are subtracting each other, you can split them. You can go back to this side. Okay, even here when you're multiplying two powers, you can also write them in that way. So this thing, just a two-way thing. Okay, so you see when we get to the application of indices, sometimes we may need something like this, sometimes we need something like this. So sometimes we'll be forced to take something that is written in this way, we take it in that way. Okay, so let's move on to the fifth one. I hope that one is clear, friends. Okay, so the fifth one is, okay, so we have a raised to the power m over n. Okay, now this time around it's a fraction. Now we want to know what is a to the power a fraction. Okay, remember again, I'm saying this power say or indicates or shows you how many times you're going to multiply this by itself. Okay, so like when it's a fraction, how are you going to express that? So it's a bit tricky again when it's a fraction. Okay, so how do you break this one down? Okay, so this one is the same as, okay, write it as, okay, so this denominator comes here. Okay, so determines the nth root. So this denominator comes here and you have a raised to the power m. Okay, so this is how you split this one. Okay, so you introduce a root. Okay, so this root will be according to the denominator. So if it is 2, it's going to be the square root of a to the power m. Okay, so what I'm saying is when you have a base raised to a fraction, okay, so this m, so you write as a root, the root symbol like that, then this n comes here and this m becomes the power of a. Okay, I hope this one is clear, guys. Okay, just to give you a further explanation on this one. Okay, remember we said a, this one can also be written as 1 over n then to the power m. Okay, so this is the same as, okay, sorry, so this is the same as the root of a, okay, to the power n then raised to the power m, like that. Okay, I hope it is clear, guys, but I like it, I like the first one. Okay, so let's move on to our 60th law. Okay, so this law states that if you raise a to the power negative, sorry, to the power 0, you should always get 1. It doesn't matter what base you have, as long as you raise it to power 0, the answer is 1. Okay, friends, so this is all I can say about the laws of indices. The laws of indices. Okay, so the laws of indices, these are the most important ones. Okay, let me just take you back to the first one. So the first one is when you multiply numbers of the same base, you add the powers. Okay, so this is the first one. Multiplying numbers of the same base, you add the powers. Okay, we move on to the second one. When you divide the numbers of the same base, as long as you're dividing, you subtract what? The powers. So what you should always look out for is the base. Are the base the same? Is there any way you can make the base the same? So if the bases are the same, then you can apply this law. Again, you will have an index of an index. This a is raised to the power m, again raised to the power. What you can do here, you can only multiply the powers. Okay, then a base raised to the power negative to the negative power. This is how you can simplify it. And this one again, a raised to the power m over n is equal to, okay, so you split them. So this a and I root, okay, and I root, then let me write it again. I'm sure it's very confusing to some of us. Okay, so we are saying a raised to the fraction. So start by writing your root, then you say you take the base is what is a, you put the base here. Okay, then you go back to your fraction, the denominator, which is a, comes here, and your numerator goes there. Okay, so this is our fifth law. Okay, then our 60th law is a less to the power 0. So it can be any number, anything less to the power 0, it's always 1. No matter how big, how small that figure is, as long as you raise it to the power 0, the answer is always 1. Thank you so much, guys. I hope you learned one or two things. Please join me for another video. We'll look at the examples. We see how we can apply the laws of indices. Thank you so much.